Hey kids, welcome to another video. This is grade 5, module 2, lesson 11. And the objective today is similar to yesterday or the previous video, lesson 10, multiply decimal fractions by multi-digit whole numbers through conversion to a whole number problem and reasoning about placement of the decimal. So in order to get it to a whole number problem, we are doing the same strategy as lesson 10. Instead of having only tenths today, we are really thinking about hundredths most of the time. And I'm going to say most of the time because be on guard in case they throw in something else. But taking this problem like 7 and 38 hundredths times 41, looking at approximately what we should have as our final answer, like 7 as a whole number times 40, make it easy so that you can solve it and just get to an approximate number of digits you should have, or approximate number like say 280, so we need something around 300. And to figure out where the decimal would go, we're going to do the, remember to take it out and then put it back in. Take it out, put it back in. You take it out by multiplying by 100 today. Yes, the previous video, lesson 10, it was multiply by 10, divide by 10. But if you have to move it 2 places, it's multiply by 100 to move it out, shift, shift, and then divide by 100 to put it back, shift, shift, back in. Still using the standard algorithm. Now, another thing that we are going to be working on today is using the unit form to help you. Once you've taken out the decimal, you can't forget what the unit form is. You can't forget what the original value should be, because you do have to write your answer in the unit form, but then in standard form. And so this goes back to, if you haven't watched the previous video for lesson 10, please watch it. Because I do have a couple of helpful hints as far as what the old way was compared to what the new way is. So this is just kind of one of those things where during class I'll challenge the students. I'll say, okay, well, what happens if you have hundredths here, but you're multiplying by tenths here? And so the students will guess, well, where do I put the decimal? Where do I put the decimal? And so when you finally, after learning this and then kind of going back to old school, which is really kind of the easiest way, if you recognize that you have hundredths here and you have tenths here, then what we would do in the old days, we would just go 1, 2, 3 places to the right, 1, 2, 3 places to the right. So you make it match. But why does it work? Why does the old-fashioned way of just going 1, 2, 3, 1, 2, 3 work? Because when you have hundredths to the right and you multiply by tenths, you will get thousandths, just in the same way 100 times 10 would give you 1,000. And so it's giving you this place value position and telling you where to put your decimal so that you can read your answer properly. So anyway, that's the old school way connected to the new Common Core way, and that's why it's really helpful. Sprints are going to be good practice for this one. And so hopefully these notes are helpful, and let's get into the book because it's kind of got a lot going on today. So lesson 11. So we have to estimate the product first, several steps today. We also have to solve using the standard algorithm. We're supposed to use the thought bubbles to show your thinking, but we only have to do that for a couple. And then it says draw an area model, but only if it helps you. And it's not super helpful for me, but if it helps you, you should keep using that. So let's jump in and get started here. So if you have a number like 1 and 38 hundredths, you want it to be relatively close to something that you're going to get for your answer, but people think about this in different ways, okay? So if I had 1 and I'm approximately trying to get, this is easy, 32 would go to 30, but I'm trying to get as close as I can to, something I can compare for my decimal. So it's pretty easy to just say, if I have 1 times 30, I would get 30. If you have a decimal value, like if you only round it to say a 1 and 4 tenths times 30, then you have to do 14 times 3 in your head, which you can do it, but it's going to be a little bit harder. And really, I'm just trying to figure out approximately how many digits that I will have in my problem that are either to the right of the decimal, or how many whole numbers, how many ones, how many tenths, how many hundredths. So in order to have something to compare to for my estimated product, we're thinking about what to do with this decimal. So in thinking about it, we're going to multiply by 100 to move the decimal out. Okay, so this is the standard form, and they have left the decimal here, so it's just like the old school way. We're going to use the standard algorithm, but we're thinking that, well, if it wasn't here, I would have 138. So let's multiply as though it's not there. So 2 times 8, 16. 2 times 3 is 6 plus 1 is 7. 2 times 1 is 2. And then this would have a 0 here because we're done with the ones. We're really got to get over to the tens place. 3 times 8 is 24. Carry the 2. 3 times 3 is 9 plus 2, 10, 11. And then 3 times 1 is 3 plus 1 is 4. So your partial products, 276, 4140. We're going to add those up. And then 6 comes down. 7, 8, 9, 10, 11, 2, 3, 4, and then 4. Now here's old school. You go 1, 2 places to the right, 1, 2 places to the right, okay? But with our Common Core way, what we're thinking about is that if I multiplied this by 100 and got 138, I would divide this by 100 and then put it back in. So it's so much easier to just go 1, 2, 1, 2. But anyway, Common Core, they just really want to make sure you're thinking about why this is possible to count things. So moving on over here, so the 1 and 3800ths times 32, same thing. They just want you to think about 4,416, that would be with no decimal, is 100 times too large. Oh yeah, because that's what I'm thinking, right? What is the real product? And so then you want it to be close to 30. So 44 is closer to 30. It would not be appropriate to put a decimal here because 441 is nowhere close to 30. 4 is not even that close to 30. So this is about just reasoning. Again, going back to the objective, we're reasoning about where to put the decimal. So what is the real product? 44 and 1600ths. You're just taking this and you're putting it right up there. Okay, so I hope that's pretty clear. Let's move on to another one, and you'll have a few minutes to practice these on your own before we get too far away. So now if I have 3 and 5500ths, again, if you're estimating, people are going to be all over the place with this. I would just round it to 4, and then I would round 89 to 90. And I would try to keep it really simple. 9 times 4, 36, and then that has that 0 here. So you want to have a 3-digit answer, whole numbers, up to the ones place, or thereabouts. We're just trying to get close. So here, for the thought bubble, they're saying, what should you be thinking about? Well, 5th graders are probably thinking, there are 2 places to the right of the decimal. But we'll think about it like they did. So we're going to think, let's take the 355 and we'll multiply it by 100 because we want to get that out of there. Okay, so let's now pretend that this doesn't have a decimal there. And we'll use the standard algorithm to proceed. 9 times 5 is 45. And then 45 again plus 4 is 49. I almost said 49 to begin with. And then 27, 28, 29, 30, 31. So done with the ones, move over to the tens, and then start multiplying with your 8. 8 times 5 is 40. Carry the 4, it's already there. 8 times 5 is 40 plus 4 is 44. Carry the 4, there it is. 24 plus 4, 28. So add these. 5, 9, 5, 9 to 11, and the 3. Now, here's where you have to think. Now remember, we're thinking about this being way too big. Too big. 31595 is too big. And so what do we have to do? We have to take this 31595 and we have to divide by 100 because we have to do the opposite of what we were thinking about doing before, which was I got to get the decimal out, but now I have to put it back in. And so the real answer, 31595, would put the decimal here, and then you get something that is a whole lot closer 315 is closer to 360 than 31,595. But old school says count 1, 2, and then put in 1, 2, and you're done. So I like the old school personally, and I will always be a big fan of old school math when it's better. And let's just say it's better for this particular skill. Now this one we get to use solving using the standard algorithm without the thought bubbles, so I was like that. And this one's pretty straightforward. We're going to do 5.04 times 8. Okay, now standard algorithm, if I had 504 times 8, I'll just show you both ways. This would be hundredths times ones. Now let's do the multiplication. 8 times 4 is 32. Carry the 3, but it falls right down because 8 times 0 is 0, and then the 3 here in the tens place. Then the 8 times 5 is 40. Now there's only one digit here for this factor, so we only have one line. But old school, 1, 2, place it. New way, we're still multiplying. Same thing, we're going to have the same digits. 8 times 4 is 32, up, down, and then the 40. So you still have the same digits, 4, 3, 2. Hundredths times ones would be hundredths. But then if it's 4,032 hundredths, that looks like 40.32. Okay? So that's what this is. This is Common Core way. This is old school. You get the same answer. So we're using the strategy and reasoning about the placement of the decimal point. Okay? And again, what if I had 5 times 8? I would have 40. So I'm trying to have a reasonable answer. Now here's a nice doozy for you with many, many digits. 147.83 times 67. This will be fun. Okay, now 7 times 3 is 21. And then 56 plus 2 is 58. And then 49 plus 5 is 54. And then 28, 33, sorry, mumble jumble. 7 times 1 is 7 plus 3. It must be late in the day. 103,481 as your first partial product for your 7 times all that. And then we're going to hold this spot and move on to the 6. 6 times 3, 18, carry the 1. 48 plus 1 is 49. 42 plus 4 is 46, carry the 4. 24 plus 4 is 28. And then 6 times 1 is 6 plus 2 is 8. And so second partial product, 886980. And remember, don't put any decimals in the middle. They don't belong in here. Okay, now we're going to add. So bring it down. 8 and 8 is 16. 9 and 1 is 10 plus 4 is 14. 6, 9, 10. Carry the 1, 9, and 9 again. Now, standard algorithm. If this is with the decimal, this would be hundredths here. It's hundredths here. So put the decimal in. 9,904 and 61 hundredths. Okay, so standard form answer, but it's because it's hundredths here times ones makes hundredths. Okay, next. 4 digits, 83.41 times 504. And again, it's hundredths, so your answer will be hundredths. 4 times 1, 4. 4 times 4 is 16, carry the 1. 4 times 3 is 12, plus 1 is 13. Then I have 32 here, plus 1 is 33. That's done. This 0 times everything means 0 tens. Move to the hundreds place. 5 times 1, 5. 5 times 4 is 20, carry the 2. 5 times 3 is 15, plus 2 is 17, carry the 1. 5 times 8 is 40, plus 1 is 41. Add all those up. 4 comes down, 6, 8, 3, 7, 3 is 10, 2, and 4. Now, where do you put the decimal? I always ask my students, between which 2 digits do you place the decimal? 1, 2 here, 1, 2 here. Okay, so your final answer is 42,038 and 64 hundredths. And so, again, if you want to double check, you can round your factors and then just get a simple, here's my 40. I have 1 0 from the 80 and 2 zeros from the 500. I have 40,000 here. I have 42,000 here as the whole number. You can kind of disregard it when you're rounding because I just want to know if I placed the decimal right. Okay? And I did. And so that, again, goes back to that objective. Okay, here's a fun one. Now, this one I will typically solve it both ways. I'll do 5600ths on top, and then I'll do 432 on the top. Now, for this one, I'm going to do 432. I usually, if I have lots and lots of time, I'll do it both ways, but on the videos, I'm always trying to go fast. So if you have a 0, if you have the option of putting the 0 on the bottom, put it on the bottom because it makes fewer partial products. So here we are, we have 5600ths, and again, if you write it the Common Core way, you would have hundredths here, but we can go ahead and just use the standard algorithm. 6 times 2 is 12, carry the 1, 18 plus 1 is 19, and then 24 plus 1 is 25. Done with this, hold that spot. Next position. 5 times 2 is 10, carry the 1, 15 plus 1 is 16, carry the 1, 5 times 4 is 20 plus 1 is 21. So now, why did I put the line there? Well, because 0 times everything is 0, and 0 will not impact these partial products that I already have. And I know that this is hundredths, okay? And you don't have to double label it. If you put the decimal, you don't need the word. If you don't put the decimal, you need the word. So it's one or the other. You have to label it somehow. So adding 2 plus 0 is 2, then 9, then 11, 2, 3, 4, and 2. So where do you put the decimal? Between which two digits? If it's hundredths here times ones, it's hundredths here. 241 and 92 hundredths. Using that standard algorithm and either the old school or the new school way to place your decimal. Now, for number 3, it's really about reasoning. So use the whole number product. Whole number would be like 241. Use the whole number product and place value reasoning to place the decimal point in the second product. And then explain how you know. So really the explanation is going to be very important. So they've already done some work for us. We're not solving these. Look, they gave you the answer. Or is it? Or is it? If this is the answer for the whole number multiplication, then the same digits would produce the same digits, 7, 5, 2, 6, 4. The only thing that's different here is that if 98 is the same and the 7, 6, 8 are the same, however, not in the same place value positions, the digits for your product will be the same, but the placement of the decimal will be different. Okay? So for the first one, it's ones times ones makes ones. Ones, ones, ones. But this is ones times hundredths. I'm writing it out because it's that important. We have hundredths here. So if you have ones times hundredths, you will get hundredths in your answer, which means put a big old fat decimal right there between the 2 and the 6 to show that your answer would have 64 hundredths in your final product. Okay, does that make sense? So the 75264, that's the answer. You shouldn't have to solve that. But basically what your explanation is ones times hundredths yields hundredths. Okay? Isn't that a great word? Yields. Okay? Like this, leading to that. So this one, if you continue with this same idea, and we have the 73 and the 1563 and the 73 and the 1563, but 1563 hundredths. So the digits for your answer would be 114099. But where would you place the decimal? Well, I need hundredths. So it's the same explanation. Ones times hundredths, or hundredths, yields hundredths. THS, don't forget the THS, okay? Sorry, it's kind of sloppy. Just apologize right now. So then for the last one, we have, oh, there go the lights, and my phone is going like crazy. I'm just going to put that on Do Not Disturb. Okay, so we have our 46 times 1, 2, 3, 9, same things, but watch out, okay? This had hundredths. This had hundredths. What does this have? Tell me now. That's right. Ones times tenths yields tenths. I can write my explanation right now, and then I'm going to write my digits. 5, 6, 9, 9, 4. But I need tenths, so where's the decimal go? It goes between the 9 and the 4, and that would be your final answer. So I hope that one made sense. It makes a lot of sense to me, and I hope you could see how that worked there. Okay, 2 little word problems here. You guys got this. And then that'll be it for today. Oh, and click subscribe and come back again. I'm going to try to be real helpful with these videos this year. Jenny buys 22 pens that cost $1.15 each and 15 markers that cost $2.05 each. How much did Jenny spend? So it's such a real life problem, more like a teacher thing, because who needs 22 pens, right? So Jenny buys 22 pens that cost $1.15 each. Okay, so what do you do if you have a decimal in your multiplication problem and you have to multiply it by 22 of them? Well, first of all, you don't panic because you can just do the 115 times 22 and you can call it hundredths. Okay, and then you can call your answer hundredths. So let's use the standard algorithm. 2 times 5 is 10, 2 times 1 is 2, plus 1 is 3, and 2 times 1 is 2. Hold this spot with a 0 because you're done there. Shift over to the tens. 2 times 5 is 10. Carry the 1, it's already there. Let's use that one. 2 times 1 is 2 plus 1 is 3. And then 2 times 1 is 2. And again, we should have the same answer because it was 2 and a 2. Same thing, right? 230, 230 with an extra 0. Add down 3, 3, 4, 5, and the 2. Where do I put the decimal? Now remember, after you do your multiplication, you're going to have to label. Why can't I not do a U and an N? Hundredths. Abbreviated. Okay, so we want to make this hundredths. And again, with money, notice this is going to be your dimes and this is your pennies. Okay? In U.S. currency, this is going to be the hundredths place because you can fit 100 pennies in a dollar, which would be here. And you can fit 10 dimes in a dollar, and that is this position. Okay, so we have $25.30 for pens. And then for the other one, the markers that are much more expensive, $2.05 for 15 markers. Again, it's hundredths. It's the same thing. You can write 205 with no decimal and then put the decimal back in. So it's multiply by 100, divide by 100. But let's solve it. It's right here. 5 times 5 is 25. Carry the 2. It falls down. 5 times 0 is 0. And then plus 2. 5 times 2 is 10. Hold that spot with a 0. And then 1. We love the 1 because it's 5 and 0 and 2. And then we add those. 5, 7, 0, 3. Put the decimal back in. It should be $30.75 for markers. That was a long M. $30.75. But that's not the end. How much did she spend? We're going to take our $30.75. Let's do it over here. And we're going to line up so carefully with the 25.30. Okay, now remember, when adding with decimals, you line up by the decimal, you anchor it, and then you don't, we're not multiplying, we're just adding it up, straight up and down. 5 comes down, 7 plus 3 is 10, carry the 1, decimal down. Do your little fun thing. 5 plus 1 is 6, and 3 plus 2 is 5. Bring your dollar sign down, and you should end up with $56.05, and you can say she spent. There you go. And you can make a neater 0 than I did, and I will maybe make it pretty. Yay, so pretty. Okay, and the last one, a living room measures 24 feet by 15 feet. I'm going to straighten it out for you. You're welcome. 24 by 15, and adjacent, which means right next door, square dining room measures 13 feet on each side. That means it's a square. If carpet costs $6.98 per square foot, what is the total cost of putting carpet in both rooms? So one thing that they throw at you a lot is this, which is the formula to find the area. This stands for area. This stands for length. This stands for width. So if you want to find how many squares would cover, like for carpeting or for sod, for grass, or things that cover squares that are flat, like a square area, then you have to multiply those. So we're going to do the LR. That's the living room, and it's 24 by 15. And so we're multiplying the length times the width. 5 times 4 is 20, and 5 times 2 is 10 plus 2 is 12. Done here. 1 times 4 is 4. 1 times 2 is 2. And then add, add, add. And so we get feet squared for the living room. That's only one, and we need the dining room as well. Now this one is 13 feet on each side, so it's 13 by 13 when multiplying the length times the width. 3 times 3, 9, 3 times 1 is 3, and we will get the same thing here, but, sorry, 1 times 3 is 3, and 1 times 1 is 1. So not the same thing, my bad. 9 plus 0, 9, and then 6, and then 1, and that is also feet squared. So we have to figure out what is the total number of feet. So we're going to put together our 360 and our 169. Add those up. 9, 12, 3, 4, 5 feet squared for both rooms. Okay, but that's not answering the question. The question is about cost. So now we have to go to the cost, $6.98, and we have to multiply it by 529. Big problem. Not for you, though. $6.98 times 529. Not a big problem if you know how to do the standard algorithm by multiplying by 100 to take it out and dividing by 100 to put it back in. Or the old school way of just saying 2 places here, and then my answer will have 2 places. 8 times 9, 72. Carry the 7. Ooh, 9 times 9 is 81. Plus 7 is going to be 88. 9 times 6 is 54, plus 8 is 62. I can tell when I slow down, I'm like, what? Okay, and then next one, hold that with the 0. It must be late. I said that earlier, though. 8 times 2 is 16. I must really be tired. 2 times 9 is 18, plus 1 is 19, then 12 and 13. And next one, 0, done, and 0, done. Remember to have that little pattern of zeros because each time you go over, you're going to have another one. And then 5 times 8 is 40. Carry the 4 this time. 45 plus 4, 49. Carry the 4. 30 plus 4, 34. Let's add up all these numbers. 2 falls down. 8 and 6, 14. Carry the 1. 10 plus 2 is 12. Ooh, look, another 10. 10 plus 6, and then 19. 4, 5, 6, and 3. So you end up with, where do we put our decimal? Between which two? And if you say the 2 and the 4, I would say which ones? So the hundredths here, or 2 places here, 2 places here. This is money. Okay, so who is it? Blah, blah, blah. It doesn't say. Carpet would cost $3,692.42. Don't forget the dollar sign, and for both rooms. There you go. And I hope this was helpful. Come back again, and we'll see you on the next video. Bye for now.